Hello and welcome. We'll get started right away. Hot or cold drink ready? We want you to have a good time at our live event. Our experts are looking forward to it. Are you ready? Then let's get started.
So, a new week, a new live event, and first of all, ni hao, konnichiwa, merhaba, namaste, good morning from Germany, and I would like to welcome all the participants who are joining us from all over the world. I hope you're all well, in a good mood, as you watch this live event. My name is Marco Samland. I'm Cutino Campus Manager, and I'm your digital host and moderator for today's live event titled Improved Wet Adhesion and Scratch Resistant in Coatings with VISIOMER MEEU Monomer. Also, a Cutino Campus World Premiere. So it is the first live event of our colleagues from the Oil Additives business line. And welcome. Yeah, good that you are here. So, as your moderator, it's my pleasure to guide you through today's session. But before, however, I would like to highlight a few important points. The short video was our trailer for the Cutino campus, where we'll find not only today's recording as soon as possible, but also all other recordings, including presentations, other live events, e-learnings, coaching glossary, and much more. Wow in know-how. Your questions fit well with our answers, so if you have any questions, please use the chat function. I will have to post the incoming questions again, so don't be surprised, but that's the way it is at GoToWebinar. And we encourage you to actively participate in today's live polls. Let's waste no more time and join me in welcoming today's expert and, ladies and gentlemen, Buffon Ge, Technical Service Engineer. Buffon, I hope you can hear me and see me, and I will let you know I can see you. Maybe.
Hello.
Yes, I can hear you. You have the permission to share your final slides with us. And then I will, of course, let you know. And first of all, welcome to our digital Cutino campus stage. Yes, you can share it now. Yes, we can see the normal presentation. Now we need the presentation mode. And then I will throw my digital microphone to you. Yes, Buffon, the stage is yours.
Okay. Thanks, Marco, and very appreciate for your passionate introduction. And hello, every online friends. Welcome to today's webinar. And I'm Buffon, the technical engineer from the business line of Special Methacrylates in Evonik. It is my great honor to be here with you today, participating in the online webinar honored by Katina. And our Evonik provides a virus solution for special methacrylate. And I believe many of you have already heard or used our Evonik VISIOMER monomer for a long time. As you have answered those two questions, I hope you already get some general ideas of our today's topic is about VISIOMER MEEU. MEU is an efficient monomer that can significantly improve the weight adhesion of coating by hydrogen bonding to the polar substrate. I hope today's lecture can bring a new solution to all of you technical experts during product development. So today's lecture can be divided into 4 parts. And first, I will provide a detailed introduction to the product specification and the chemical mechanism of MEU. And next, I will demonstrate its performance in pure film after emulsion polymerizations. And then I will show its performance in the final coating formulations. And finally, I will share the guidance and the conclusions. The right figure in the corner shows the structure of our product, VISIOMER MEEU. So next, let's open our monomer toolbox like the picture shows to find the instruction manual of MEU to look at its product specification and the chemical mechanism. Actually, we offer 2 product specifications, MEU25M and MEU50W. MEU25 is solution of 25% MEU in 75% messy methacrylate, which can be easily used in water-based, oil-based, and reactive system. And MEU50W is a 50% aqueous solution, which is convenient to use in the water-based system and do not contain MMA. And the table below shows the specification of those 2 products, such as MU content, active ingredients, water content, and color. Both of them have a light yellow appearance, and the stabilizer content. We guarantee that all indicators will be within those range for 6 months after our customer receives those products. And next, here are the safety information for those 2 product specifications. Since MEU25 contains about 75% MMA, it has more chemical hearts. It should be handled as a dangerous goods during the transportation and the storage. While MEU50W, more safety, could be more suitable for water-based products. So, how does the MEU monomer work? We all know that the adhesion of emulsion coatings to the substrate is reduced upon the contact with moisture. The consequence is blister and cracks. So our VISIOMER MEU have such advantage like excellent weight adhesion and increase the weight scrap resistance. Meanwhile, only low concentrations required, 0.5 to 3% by the weight of the binder, and do not bring problem in the reaction, which means it easily incorporates into the binders. And one of its typical application is as a synthesis component in emulsion ester coatings to improve the adhesions under humid condition, especially on wood or aged anki paint surface. The key to improving adhesion is the urea structure on the MU side chain. Compound continuing urea structure often have a variety of activities, which become one of the dominant fragments of material in many chemicals, as shown in the figure below. Two amino groups are joined by an intermediate carbonyl group to form a urea group, and the oxygen atom on the carbonyl group are hydrogen-bound acceptor, and the amino group provides 2 to 4 hydrogen bonds as donors. Therefore, urea have a superhydrogen bond, as the figure shows, superhydrogen bond forming ability, which can form a very strong intermolecular hydrogen bonds. Whereas MEU monomer is a combination of double bonds and a urea group, the double bonds of the methacrylate gives MU the condition to attach the polymer backbones by the thermal initiations, and the structure provided by HEU is a cyclic urea-based fragment. And the structure contains only one hydrogen bond donor and one acceptor, which we have verified that such structure is more likely to produce hydrogen bonding with the surface of the polar substrate, like the middle figure shows. It improves the adhesions with the polar substrate. And of course, it also forms intermolecular hydrogen bonds, improves the cross-linking density, thus improve the scratch resistance. It is suitable for all kinds of radical polymerizations in the synthesis process, and lots of patent and literature have confirmed it also can be used in polar plastic, laser, paper, and textile industries. So then let's get down to the experiments part. We use VISIOMER MEEU in a typical emulsion polymer synthesis, explore some of its characteristics during polymerization. Then those emulsions were formed into film, and we explored the pure film property in this section. Our research team first designed a series of emulsion formulations containing different ratios of MEU monomers. Meanwhile, we also try to differentiate the difference between MU25M and 50W. Here is our guide formulations on the left side. We took the self-nucleation and semi-continuous emulsion polymerization process. The high glass transition temperature monomer is MMA with the addition amount of 40 to 44%, and the low glass transition temperature monomer is butadiene. The addition amount is fixed at 55%, and 1% methyl acrylate acid is added to maintain the stability of the emulsion. And the active content of MEU varied from 0 to 4%. It is a quite simple reference formulations. To facilitate the film formation at room temperature, we designed the glass transition temperature of the whole film to be about -10 to -6 degrees. And you can see the right-hand side picture is our reaction device. Here comes our performance characteristic of the emulsion follows. And it can be confirmed that there is no problem with the conversion of MU monomer because we get the solid content, viscosity, and the pH are quite stable. However, when you see the figure on the left side, the cracklin content increased with the increase of MU monomer. The reason behind it is MU is a hydrophilic monomer, which may easily cause particles to agglomerate once the dosage is very high. In the figure, it shows over 3%. The cracklum grows very rapidly. And if we look at the right-hand side chart, the increase of particle size may also be the thickening of the outer layer of particle caused by those hydrophilic monomer. Therefore, due to the MEU hydrophilicity, high dosage can lead instability in the emulsion. So we recommend lower than 3% is the low-risk dosage. And then for the pure film application section, after emulsion or synthesis, we apply a 200 micrometer weight film to the glass plants, cool it for 24 hours at room temperature. And to test the water resistance, we soak the cooled film in water for another 12 hours, or reverse the whitening of the pure film. If it is whiter, it means that more water has entered into the film, which shows the water resistance is poor. The film that has been immersed in water shows on the left side picture. The same result is reasonable. More MEU monomer decrease the water resistance. Therefore, when you choose to use MEU in your formulation, you should pay more attention on the impact of the decrease of water resistance. And then, after soaking in water, the adhesion of the pure film on the glass plant can also be roughly evaluated by a very simple manner. It's called hand rubbing. The harder is to be destroyed by hand, it gets a higher score. So if you see the chart on the right, it can be seen that 1 to 2% Mu 25M and 2% 50W samples performance best, proving it improves the weight adhesion. However, more Mu leads to poor water resistance, which affects the overall performance of the pen film. So when the dosage of MEU over the suitable amount brings some negative effect, as the figure shows, the rubbing resistance decreased. So we got some conclusion as before. When you design the formulations by using MEU, you should balance the water resistance and adhesion. And next, let's focus on the dry adhesion test. These samples were tested according to the American standard ASTM D3359 coating scratch resistant method, and the emulsions were coated on PVC board, which is a kind of polar plastic, using a multi-layer scrubbing knife to line and tear with a standard type. Scratch resistance is judged according to the state of the grid lines, as shown in the image on the left side. Higher number means more film peeling off and worse performance. And the result shows on the right side have the same trend. Blank sample shows the worst result, and 1 to 3% Mu dosage shows a great improvement of adhesion, while Mu has an optimal dosage. Over that, it will decrease the performance. In addition, we also tested a group of emulsion pure films containing Mu with a TG of about 10 degrees by differentiate scanning calorimeters. Through the DSC test, it was found that the actual glass transition temperature was higher than the theoretically glass transition temperature by calculate. The increase of MEU will also lead an increase in TG. This phenomenon may be due to the increase of the degrees of physical cross-linking caused by the hydrogen bonding produced by MEU. So we did pure film swelling experiments to verify this hypothesis. So first, in this slide, let me explain what is the swelling method. It is to measure the degree of cross-linking. In the specific swelling experiments, each pure film samples were cut into regular cube of appropriate size, soaked in a DMSO solvent, and placed in oven at two different temperatures, 40 and 70 degrees. The swelling index at 40 degrees showed the degrees of cross-linking when the hydrogen bond was not be destroyed, while the swelling index at 70 degrees was impressed as the degrees of cross-linker after high temperature destroyed the physical cross-linker partially. Physical cross-linking index is the 40 degrees index divided the 70 degrees index. It could roughly represent our assumption that MEU increased the physical hydrogen bond cross-link density. The result shows in the figure in the chart confirmed our assumption. The swelling degrees of 40 degrees was much lower than the swelling index of the 70 degrees. It means the high temperature destroyed the physical cross-linking points. Therefore, MU could improve the physical cross-linking density, which may be one reason is to increase the mechanical property of the pure film. And in the next part, I will introduce the performance of MEU in two typical application directions we recommended: the construction plant and the industry plant. To this end, we have reproduced a series of emulsion based on the typical glass transition temperature of acrylate emulsion in construction and in industry plants. This is our guide formulations. Just adjusting the ratio of MMA and BA, we designed 5 sets of acrylate emulsion for construction pants with a TG around 10 degrees, and 3 sets of acrylate emulsion for the industry plant with a TG around 40 degrees. And based on the previous experiments, the addition amount of MEU was optimized to 0 to 2% and 0 to 1%. To better control the particle size, the process we changed to the seed polymerization, which means use a seed to replace the self-nucleation. And here comes the analyze part. According to the analyze, the particle size by DLS was well controlled through the seed polymerization, and the solid content viscosity were quite stable in this time. And here comes our formulation. The table on the left side shows our guide formulations of construction paint. Most additives are provided by Evonik regular Tigo products. The field forming emulsions of it is the series of emulsion we synthesized before, accounts for 37.5%. Based on the typical experiments in construction paint formulations, we designed the pigment volume concentration at 25, powder base ratio at 0.66, and SOP at 5. The viscosity of all formulations were controlled between 85 to 95 KU. So in order to test the effect of MEU on improvement of adhesion in construction pans, this is a wash-resistant test done according to the external wall coating scrap-resistant method, ASTM D2486. After 1 day, pans were coated on the standard cement board and cured for 1 week at room temperature, and the dry film thickness controlled at 15 micrometer. As shown in the picture, the scrubbing instruments were applied, and the scrub of the pan film back and forth were recorded as one circle. And until 2 centimeter length of the substrate is exposed, which would be regarded as the pan film fillet. And then the number of scrubbing circles was recorded. And then let's see the result. Look at this picture. The left is the blank control sample, and MEU25M-1 represents 1% MEU25M emulsion used in the formulation, and the same with the 50W. And this picture in the middle is the dosage 2%. It can be seen that the number of scrub are significantly improved after the addition of MEU monomer. The blank control samples have 3,000 times, while the formulation with 1% MEU contained emulsion increased the scrub resistance to 4,200 times. It means 40% improvement. And the formulation with 2% increased the scrub resistance even to 6,000 times, which means 100% improvement. MEU50W shows a better performance than MEU25M in this case. Therefore, the addition of MEU significantly improves the scrub resistance of the coating during its enhanced adhesion to the cement substrate, which is one of the most important mechanical property for the construction pans. And similar to the construction pan formulation, we redesigned the industry pan formulation with a PVC of 22. And in this formulation, we also added an anti-flash rust agent. The viscosity was controlled between 67 to 69 KU. In the case of industrial pans, the anti-rust and scrub resistance are critical property. So the salt spray and scratch tests were performed to investigate the performance of MEU. The salt spray resistance test is based on the standard ASTM 117. The industry pan is coated on the air plant for 1 week of curing at the room temperature. And a line was cut in the middle to expose the substrate. If you can see in the figure, there have line in the middle of the pan. It's just for accelerate the corrosion rate. And the result picture in the below shows the addition of MEU does not improve the salty spray resistance. However, it can be seen that the pan film around the acceleration line of the blank sample had been peeled off, while the sample with MEU did not, proving the improvement of adhesion decrease the spread of rust. And the scratch resistance of industry pans was tested based on the ASTM D5178 standard. As the picture on the right side shows, the scrub resistance has also been improved after adding MEU. Not only has the number of scratch resistance increased, but the area of damage to the paint film has also decreased, which demonstrates improved adhesion to the metal substrate. So the result shows MEU cannot directly improve the salt spray resistance, but can improve the adhesion on metal substrate and slow down the spread of rust. So, last but not least, let's make a summary of MEU synthesis consideration and performance improvements. So the first is MEU monomer rely on the hydrogen bonding with substrate to improve adhesions. In emulsion synthesis, MEU monomer decrease the polymerization stability, and its optimal adhesion ratios is 0 to 3%. And in pure film, MEU monomer reduce the water resistance. 1 to 3% MEU monomer improves adhesion to the substrate. In the construction extra wall coating, MEU monomer can significantly improve the wash resistance and improve the adhesion to thermal substrates. And in the light anti-corrosion industry coating, MEU cannot directly improve the salty spray resistance, but can improve the adhesion on metal substrates and slow down the spread of rust. So, this is my content for today's lecture, and thank you very much for listening. This QR code is our website of our VISIOMER Specialty Methacrylates family. You can use it to check our product portfolio to find the most suitable functional monomers to enhance your product performance. In addition, you also can see our next generation solution products. So now, if you have any question, please feel free to ask by typing them in the chat box.
So, first of all, many thanks, Bufonge, for your insights, for your presentation. There are 2 live polls. Would you like to share them, or shall we go directly to the Q&A session? It's up to you.
Just to show now.
Yeah. Okay, so shall I start the first poll for the audience?
Yes.
Okay, so dear audience, we would like to start in total 2 live polls for you, so please actively participate, and then Buffon, of course, will then go into more detail. First of all, the first question, as you can see, which substrate below that MEEU cannot improve adhesion? And there are some answer possibilities, so please click. And after some seconds, we will go back to Buffon. So first of all, please start the voting. And after the voting, we will definitely go into the Q&A session. So yes, it started. And there are a lot of questions, so also good to see. Thanks for all of you. I will write them down and then go into more detail. But first of all, back to the first polling. Yes, 40% voted. Good to see. Thanks. Very good. I will wait. We are now over 50%. Still increasing, so I will wait. We're near to the 60%. So, okay, so I would then maybe stop the first polling and share the final results to all of you, and Buffon, of course, can then go into more detail and say something about it. So I will close and share. So as you can see, Buffon, hopefully, if not, I can help you. But 56% said non-polar plastic, and then 25% glass, then cement on with 11% and 8% wood.
Yeah, I'm very happy most of you are correct, because I mentioned Mu contribute the hydrogen bond with the substrate. So we need the substrate have a hydrogen bond acceptor. Like no polar plastic, it doesn't have the hydrogen bond acceptor. So our Mu cannot very suitable for use on the no polar plastic. Thanks a lot for your answer.
And then I will hand over my the second poll, right? So I will first of all hide, and then only the last one for today's live session. Here we are. What are the main application for MEEU monomers? So please feel free, dear audience, and don't forget to drink while clicking. And after some seconds, I will hand over again to Buffon, and then we will directly groove to the Q&A session. So last live poll, please click and share your answers with us. Or a lot of incoming questions. Also good to see. Perfect. Okay, now it's 62% voted. Good to see. So more than the first poll. Very good. Thanks to all of you. Okay, a lot of incoming questions. Also good. And now I would say I will stop the second polling for today with 65% voted. Thanks again. And I will close and share the final results. And as you can see, Buffon, 78%, all of the above, and then only 15% construction coating, 5% industrial coating, 1% wood coating.
Actually, all of those sections are correct, because Mu can be used in those directions, because it can contribute the hydrogen bond into the substrate. And congratulations to all of you. You're all correct.
Okay.
I think we can go to the question section.
Correct. And I will do my best. And of course, our dear expert Buffon girl will also do his best and answer as good as possible. If there is, Buffon, a question who can't answer directly because you need more details, more information, that's definitely already okay, then please say it. And of course, the audience contact Buffon directly, yeah? But of course, we will now start with the first and then step by step, because there's 20 minutes left, so already good to have a look on the incoming questions. So I will start with the first question. 2 screens, so now I'm clear. Can MEEU be used in adhesive like PSA or structure adhesive?
Oh, yes, of course, because its features, it can be used in adhesive. For PSA, pressure-sensitive adhesive, it can synthesize in the resin, and for structure adhesive, it can be added in the formulation as a reactive component to improve the adhesion and cohesive. Because the conversion of MEU is no problem to use as a reactive component.
Yeah.
Hope the
All
answer
right.
is helpful.
Does MEEU 50W is feasible to using in polymerization stage during preparation of latex emulsion?
Yeah, definitely yes. If you do a water-based textile emulsion, you can use MEU50W since MMA have a high order problem.
Is MEEU improves also the adhesion on fresh concrete?
Fresh concrete, yeah, definitely yes.
Mm.
Any substrate can contribute the hydrogen bond with this kind of monomers. It can improve the adhesion.
How to translate the performance of MEEU in the paint film if the selected binder in the paint is incorporated with MEEU? Once again,
Sorry,
or
yeah, once again.
yeah, I will try my best.
My
So it's
net
in
not
the
quite.
questions. Yeah, how to translate the performance of MEEU in the paint film if the selected binder in the paint is incorporated with MEEU. If not, it's okay if we say we will answer after. Yeah.
I'm not quite get the point. Because MEU can be synthesized as the binders, and the binder is one part of the whole formulations. The binder is used to make the film. So MU inside the binders and explode to the surface of substrate to contribute the hydrogen bond between our film to the substrate.
Okay. Let's hand over to the next one. If higher MEEU dosage will cause worse water resistance, how can it improve the wet scrub resistance? Are these two parameters correlated?
Yes, to some sentence, MU could decrease the water resistance because it is a very hydrophilic monomer. But if you add in a very suitable ratios like 1%, 2%, it will balance the performance of the adhesion and the water resistance. So it can improve the adhesion when the dosage in a very suitable ratio. Yeah, but you should pay more attention to not add too much. It will decrease the water resistance.
Okay. Does MEEU 50W improve alkali and salt resistance properties of paints?
The resistant property of things.
Yeah.
Yes, it can. It can improve the salt resistance, but it's not directly improve the salt resistance. It can only increase the adhesions, so the rust cannot spread very fast. If you want to directly solve the salt resistant problem, I recommend you use another VISIOMER monomer called HEMA-P, which is a phosphate monomer, can contribute a very strong bond with the metal substrate.
The next one. Do you have any data in which the MEEU 25 is compared to pure methyl methacrylate, I would like to know the effect of methacrylate itself.
To pure methacrylate. Actually, normally methacrylate, methyl methacrylate be used as a comonomer in the synthesis. If you mean the PMMA, actually we do not have data.
Okay.
Mm-hmm.
Did you observe any effect on dirt pickup resistance?
Actually not. For the dirt pickup resistance is more close to the surface cross-linking. Actually, our MEU is to use to increase the adhesion. So if want to increase the dirt pickup resistance, I recommend to use the cross-linking VISIOMER cross-linking monomer.
Mm-hmm.
Mm-hmm.
What is the pot life after dosing the 50W?
I'll get more information and answer this question. Sorry, cannot.
Yeah, no problem. No
cannot
problem.
answer
So
now.
no problem. Please, dear questioner, contact Buffon directly, so you will get then the correct answer. No problem. Yeah. Yeah. Then
Yeah.
the next one.
Because
Slide.
Mm-hmm.
Sorry. Yeah, Buffon, please.
Yeah, because we didn't really focus on the port life of the MU50W. Yeah, but the conversion is quite good. I think it will react very fast.
Mm-hmm. Okay.
Mm-hmm.
Slide 10. What do you mean with self-nucleation?
Okay, let's go back to the slide 10.
Yeah.
I think it should be slide 8, if I understand correctly. The self-nucleation means it have a hydrogen bond acceptor and a hydrogen bond donor, so it can contribute hydrogen bond to other side chain monomer in the polymer. So it is the reason why it increased the physical cross-linking in the polymer.
Mm-hmm. Okay. Next one.
Sorry, for I misunderstand. For self-nucleations, it means that I don't use the seed emulsion polymerizations. I don't add a seed, just put about 5% monomer in the flax at first to build a space for other monomer to grow inside of the seed.
Mm-hmm.
To nucleation by the 5% monomer by itself.
Mm-hmm.
Mm-hmm.
Also, these two monomers contain same amount of functional groups. What's the main reason changing washing resistance?
It is quite hard to explain these situations. Many of our customers also reflect that in some formulation, MU25M performance better, but in some case, they mention 50W performance better.
Mm-hmm.
Mm-hmm.
Do you also provide a 100% version of this monomer?
Sorry, we don't, because MEU is a solid if it is 100%. So for more easy to handle, to produce, we just solve them in MMA and in water.
What additive do you advise to improve adhesion on non-polar substrates?
It is quite difficult to improve the adhesion on no-polar substrate actually, but we have VISIOMER long carbon change monomer, which is also no-polar monomers. It can improve a little bit on the no-polar substrate adhesion. Like C13 and C17.4. You can check with the QR code I shared before and find it.
Can MEEU improve the adhesion properties of coating to wood plastic composite?
I would say if the wood plastic composite have polar, it could be help. But if the plastic is no polar plastic, it cannot improve the adhesion.
You mentioned MEEU in radical polymerization to make acrylic emulsion. Can it be added to existing paint formulation, and what will be the impact?
Yes, it can just add in the paint formulations because its conversion is quite good, but we do not recommend it because to initiate the monomer in formulation, you need a high temperature and an initiator. Normally, a paint formulation do not include those agents. Yeah, just for adhesive, they have like application situation like that, have a high temperature and initiator. It means 2K system.
So the next one is also not so easy for me to read it out, but maybe it's easy to answer. For you, Buffon, we'll see. So does carboxylic acid group like acrylic, methacrylic acid react with urea in emulsion medium? Hopefully
No, it doesn't react actually because the urea group is quite stable. It cannot react with any agent, any function group. Yeah.
Perfect. Yeah, thanks. Can you explain swelling test method?
The swelling method is to use a solvent to swell the film, and it means the more of the volume of the film is swelled, the less cross-linking inside. It is a method to test the cross-linking density of the film. You can choose any solvent you have. In my case, I use the MSO because it's low order and a very good solvent for the polymer film.
Thank you for the lecture. Is it possible to get the MEEU monomer in pure form without MMA or water or in an organic solvent in the future?
In pure film without, I don't think it can.
Yeah, no problem. Is it possible?
Yes.
Is it possible to react? So sorry, Buffon. Yeah, sorry.
So now we only apply to specifications. Yeah.
All right, next one. Is it possible to react MEEU on TPEG, HPEG monomers with radical polymerization?
TPEG and HTG, which is very hydrophilic monomers, I think. I'm not sure actually for these questions because I'm do not do the experiment. So if you're interested, I would recommend I will send the sample to you. Please have a try.
To clarify, MEEU is a monomer which is to used in emulsion polymer synthesis and cannot be used as a post-addition additive, right?
For the adhesive, I think it can be used as an addition additive, but for coating, it can only be used in synthesis.
There are two more questions and we're very good in time. So, hello, can we use the MEEU in latex paints and what's the optimal percent?
And I think the latex means the emulsion, and our recommendation is 0 to 3%.
Perfect. So the last question in my inbox, is hydrogen bound possible also with the acrylate group?
Yes, for some acrylate group, it also have hydrogen bound donors or acceptors, so the MU can contribute the hydrogen bond with it.
Perfect. So, Buffon, that's it for today's live event. The last questions. If you have further questions, please contact Buffon directly, of course. He shared his contact dates, also QR codes, and so on. And before I will hand over to my last slide and last teaser video, I would like to give you the digital microphone again, Buffon, for your final words to our audience.
Okay, thanks a lot, and thanks again for today's listening. And this is my pleasure to share the MU information with you. And if you want the sample for sampling questions, please put your contact message with us, and we will handle it as soon as possible. And thanks again for today's listening. If you have more questions, please just send the message to Marco or me, and I will answer it as soon as possible. And hope to see you next time in the Cortina journey.
Perfect. And when you will contact me, I will postpone it directly to Buffon, of course, because I can't answer every question. So no problem. So I would wanted to share my last slides. PowerPoint is loading, so I will don't do it, but I don't need it because as I always like to say, where there is a beginning, there is an end, and it's time to say goodbye. And I would like to thank you, our digital audience, for your participation and engagement today. 2 live polls, a lot of questions, so many thanks to all of you. And as the session now draws to a close, I invite you to explore the Coutinho campus, so please visit coutinho.com/campus and discover the wealth of knowledge there. I close with a final video, so wish you all the best. Look forward to getting in touch with you again soon. Stay healthy and peaceful with each other. Yours sincerely, Marco Samland, and that's my last video. So here it is, and have a good day, good start, restful day, and so on. Bye-bye. And that's it for today's live event. Ciao, ciao. Bye-bye.
Bye-bye.
We hope you liked today's live event. Please visit cotino.com/campus to view the recording and download the handout. And there is a lot more to explore and learn on Cotino campus. 24/7 available. Free of charge. For newcomers and experts. Find all upcoming and past life events. Our experts share their knowledge. Missed the live event? No problem. Our knowledge is ready for you. All past events at your disposal. Enroll and start your desired recorded event. Of course, the handout can also be downloaded under Resources. Discover the wow and know-how. Discover Cotino Campus.